Good day everyone, welcome to Math with Teacher Justin. On today's topic, we're going to have some examples in proving triangle similarities. Alright. Okay, let's have some examples in proving similar triangles. So let's start first with proving triangle BES is similar to triangle BTB. So this is our figure. Now let's identify the two triangles. We have this triangle BES with the given measurement, and we have triangle BTD with the given measurements. Now, let's identify what postulate or theorem are we going to use. Now, looking at our given, okay, we only have the two angles of each triangle. So we can use the AA postulate. Now, let's see if they have corresponding angles that are congruent. So we can say that angle B is congruent to angle B, and then we have angle E is congruent to angle T because they have the same measurement. So knowing that two corresponding angles in these two triangles are congruent, we can now conclude that triangle BES is similar to triangle BTD. Alright, let's have another example. So let's prove that triangle WET is similar to triangle STA. So looking at our figure, we have this two triangles, and we're going to identify if they are similar. We have WET with the dimension and triangle STA with the dimension. Now looking at our triangle, we're given the measurement of the two sides and its included angle. So we will use the side angle similarity theorem. First, let's compare the angles. Okay, is the corresponding angles congruent? So we can say that angle W and angle S are congruent because they have the same measurement, that is equal to 22 degrees. Next is, let's see if the two sides are proportional to each other. Okay, so the given two sides are proportional to each other. So we will have side WE over ST because they're corresponding to each other. We will form a ratio of that two sides and equate it to the ratio of the corresponding sides WT and side SA. Okay, so let's substitute the given. We have 40 over 24 is equal to 45 over 27. Now, in order for us to identify if they are proportional, we have to simplify our fractions. Okay, so let's simplify. We will have 5 over 3 is equal to 5 over 3. So since they are equal, we can say that they are proportional to each other. So since it satisfies both conditions, we can say that this two triangle WET, is similar to triangle STA. Alright, okay, let's have another example. Let's prove that triangle THE and triangle AND are similar. So given this figure, let's dissect them into two triangles. So we have triangle THE with the given dimension and triangle AND with a given dimension. So looking at the two triangles, we're given the sides or the measurement of each sides. So since we're given the sides, we're going to use the Sss Similarity Theorem in proving these two triangles. So for Sss Similarity Theorem, we will identify if our corresponding sides are proportional. So we have this equation. We have TH over AN is equal to HE over ND and DE over AD. So let's substitute all the measurement in our equation and let's simplify. So we have 42 over 24 is equal to 84 over 48 is equal to 70 over 40. Now let's simplify. We have 7 over 4 is equal to 7 over 4 is equal to 7 over 4. So we can say that they are proportional to each other. So knowing that our corresponding sides are proportional, we can conclude that triangle THE is similar to triangle AND. Alright, okay, let's have another example. So prove that triangle ITM is similar to triangle IHS. In this figure, we have two triangles. We have ITM with a given dimension and IHS. For angle MIT, using the vertical angle theorem, they will have the same measurement as angle SIH. Okay, or looking at our given, we're given two sides and one included angle. So we're going to apply the side angle side similarity theorem. So let's check first the angles. We have angle TIM. Is it congruent to angle HIS? So it satisfy our first condition. Now for our second condition, we will check if our corresponding sides are proportional. So we will have this equation: IT over IH is equal to IM over IS. Okay, so let's substitute our given dimension. We have 45 over 120 is equal to 54 over 144. So let's simplify our fractions. We will end up with 3 over 8. So 3 over 8 is equal to 3 over 8. So we can say that they are proportional to each other. Now that it satisfies our two conditions for side angle side similarity theorem, we can now conclude that triangle ITM is similar to triangle IHS. Alright. Okay, let's have our last example for today. So let's prove that triangle BEA is similar to triangle VET. Okay. So, looking at our figure, or we have two triangles. So, we have triangle BEA and triangle VET. So, looking at our given, we have the measurement of each side of our triangle. So, we will use the side similarity theorem. So, let's formulate our equation. So, we will have BE over VE is equal to EA over ET is equal to BA over VT. So let's see if our corresponding sides are proportional to each other. Okay, so let's substitute our given. So we have 10 over 25 is equal to 14 over 35, 18 over 45. Now let's simplify if we have a common ratio. So we will have 2 over 5 is equal to 2 over 5 is equal to 2 over 5. So since our corresponding sides are similar, or since our corresponding sides are proportional to each other, we can conclude that it satisfies our side similarity theorem. And since it satisfies our side similarity theorem, we can conclude that triangle BEA is similar to triangle VET. Alright, now that you already know how to prove triangle similarities, it is your turn to try it. Please click the link in our description box below in order for you to test your skills. That's it for today. Again, I'm Teacher Justin. Goodbye, God bless, and stay safe. See you on my next video. Peace.